So i-free body diagram namhlanje, let's start with i-free body diagram ye-object ehamba kwi-surface that is horizontal. Let's say we have this surface, then we have a block here. For example, the block is 3 kg and is pulled to the right, by a force. Let's say it's a force applied. So let's say the surface is rough, that is a rough surface. The surface is rough, which means there is a friction. So upper the first force esingayizoba, which must always draw it, the force of gravity, that is Fg. The force of gravity, then we have normal force. Then when we define the normal force, we say it's a perpendicular force exerted on a surface to an object in contact with it, which means sozoba a force that will be perpendicular to the to the surface, that is a normal force. Now that we said the surface is rough, we also have the frictional force. Frictional force which is opposing the motion of an object, i-frictional force layer. Since the object imova, the frictional force is over Fk because iyamova the object. That is the frictional force, Fk wethu, or this one we said is a normal force. So this is the force diagram there. Then the free body diagram, the object is represented by the dot. So we'll have a bullet eme endaweni object. So sibene force eyehlayo, sithe intoni, if Fg, that is gravitational force, yakhuphela ke ngoku, but object yona siyayisusa sibeke ibullet endaweni yayo. Then sibene normal force, that is the normal force. Then sibene force that is applied, the pulling force to the right, the pulling force. Then sibene friction, that is Fk. Then we are done with the free body diagram yalapha. Ii-marks zayo xa kuthiwa umzekelo uyamakishwa le free body diagram, ii-marks zayo zizoba yi-4. So sinemark yokuqala, sinemark yesibini, sinemark yesithathu, sinemark yesine. So utsho ufumane u-4 marks wakho, which means xa kuthiwe draw a free body diagram bengu-4 marks, you must know that nee-forces zizoba yi-4. So that is the free body diagram for this object, free body diagram. Now let's say let's draw another object here, another system. Let's have another system, free body diagram. So a free body diagram. So let's say the same object, that is 3 kg, the 3 kg block, which is on a horizontal plane or horizontal surface, and which is rough. The surface is still rough, but the force that is applied at an angle. Let's say angle theta. So the force now is applied at an angle, force applied. The force that is applied is at an angle. Then to draw the free body diagram, why normal? It's force applied, not normal. Force applied. Draw the free body diagram. So we'll have Fg is always going down, the weight is pulling an object downwards. Then we have the force that is a frictional force, is opposing the motion and acts parallel to the surface, that is Fk. So Fk weight will always act parallel to the surface and is opposing the motion. Then we have the normal force. Then the normal force yona is perpendicular to the surface by definition, acts perpendicular to the surface. This one siyibiza by force diagram because it's object. Then i-free body diagram yethu i-free body diagram yona sizoba no-FG, i-object imelwe yi-bullet leya, then sibe ne-force that is at an angle, force applied, then sibe ne-normal force, then siyakhuphela sibe no-FG oya kweli cala, or FK I mean, FK. So nalapha is 4 marks. It's 4 marks. So we have the normal force 1, the force applied 2, the FG 3, then you get 4 marks. So here, let me draw another free body diagram which is similar to this one, which is very important for calculations. This free body diagram, normal force which is going up, that is the normal force. Then we have that force applied, then we have FG, then we have FK. But this one in a components le imele zi-components zayo. So we have i-component enyukayo, that is FY, that is FAY, then sibe nobani FAX, zii-components zale. So once uzobe i-components ke ngoku, you remove the original force, ushiye i-components zodwa. Remove original force, ushiye ntoni? I-components zodwa. So normal force, ndamcela ngerabha by mistake. So you remove the original, ushiye ntoni? I-components kuphela. So i-free body diagram nayo iyafana nale. Imark yokuqala ye-components zidibene, beyi-normal force, beyi-frictional force, be ngu-FG. Then nalapha you are going to get 4 marks. Okay, then siye kwenye is the case apho i-object ihamba kwi-incline plane okanye kwi-surface engu-incline. Sizobe free body diagram khona. Let's say here is the object. The object is moving on an incline, the 3 kg. The 3 kg is moving up, for example, by force applied. Someone is pulling the object upwards. So that's the free body diagram. FG will always go down. FG always go down. Then the normal force is a perpendicular force. We will try to draw forces that are perpendicular to the surface. These are a normal force, that is the normal force. Frictional force oppose the motion and acts parallel. So we know FK since ihamba the object. So the free body diagram here to sisanje object, we will have a force, that is applied force, then we know FG, then we know FK which is going down, FK, then we know normal force. Then you get your 4 marks. But this one in a components upper incline, which means ngana free body diagram yesibini. Free body diagram yesibini, no force applied, no normal force. You can say Fn or N. FK, FG. But FG unantoni ngoku, une components. So sibe components, nansi component yokuqala, you can draw it by a solid line. FG or parallel to the surface. Sibe nomnye FG or perpendicular to the surface. Sitsho ingu-original siyisuse, because once sibhale components original siyithini siyayisusa urabhe i-original yakho, then itsho i-free body diagram yakho ibe right, ukwazi ukufumana ii-marks zakho. Zizoba yi-4 nalapha ii-marks. So we have imark ka-force applied, that is the force applied, imark yee-components zizonke, FK and normal, then you get your 4 marks. That is the free body diagram. Then you are done. So then FG parallel will be equal to FG, that is mg sine theta, then FG perpendicular is equal to mg cos theta. Okay, that is the free body diagram. Then singanazo